In today's video, I am going to demonstrate all the activity lifecycle methods, and then we are going to focus on fixing the bug that we found in our Clicko Counter app. Hello and welcome to Learn with Tam. I'm Tariq Ali Mirza and my goal is to make you a kick-ass Android developer. If you are new here, I suggest that you watch this series from start to get the most out of it. In the previous video, I explained the Android activity lifecycle methods with a theoretical approach. In today's video, we are going to take a practical approach and create a new project to demonstrate all the different lifecycle methods. So, without further ado, let's jump right into our system and get started. Now open Android Studio. Click on Create New Project. Select Empty Activity and click on Next. Now I'll give a name to our application. Make sure that you have Kotlin language selected and that the minimum SDK is at API level 21, and then click on Finish. Before I demonstrate the activity lifecycle methods, I should first demonstrate how to use Logcat in Android Studio. To do that, I will first create a log tag. To create a log tag, simply type log t and click on tab. It has created a private const variable. We write debug messages to the Logcat window using the following method. Inside these quotes, you can write whatever message you wish to appear on the Logcat. So I will write, "This is a test," and then I will run this application. Make sure that you have the Android virtual device selected before you click on the Run button. Now let's wait for the application to show up. Nothing changes here. It is just a simple Hello World application because we did not change the layout of the activity. Now let's take a look at our Logcat. As you can see, our Logcat is currently filled with all kinds of messages. So how do we find our message in all of this? To make it easy for us to find our message within this Logcat window, change the type of logs from verbose to debug. Even then there are a lot of messages within this window. So we can use the search bar to filter them. As you can see, in our log, we had used the word onCreate. And when I search for onCreate in this window, I see only one message, and that is, "This is a test." I could have also searched using the tag that we have used. As you can see, when I search for main activity, I get the same result. So now you know how to write logs to the Logcat. With that out of the way, now I will proceed with demonstrating all the lifecycle methods. So let me first create all the lifecycle methods one by one. The first lifecycle method is onCreate and it is already present within our function. So we need not worry about that. Let's move on to the next lifecycle method, and that is onStart. I have typed out all the log messages that are required for me to demonstrate the application's lifecycle method. So let's start the application. The application is now running. Let's open the Logcat. As you can see, the first message, that is onCreate, "This is a test," was printed to the Logcat as expected. And after that, the onStart message was printed. And after that, the onResume message was printed, which indicates that the first method to be called was onCreate, then the onStart method was called, and then the onResume method was called. And now our application is in the foreground and is in the active state. Now let's see what happens when we click on the home button. As you can see, when we clicked on the home button, the onPause method was called, followed by the onStop method, which implies that the application is currently running in the background. Now let's get back to our application. As you can see, when we restarted our application, the first method that was called was onRestart, and then the onStart and onResume methods were called. which is exactly as we expect as per the image that I showed you in the previous video. Let's take a look once again at that image. When the activity is launched, then the onCreate, onStart and onResume methods are called one after the other, and then the activity is running. Let me restart this activity after clearing the Logcat. Now the Logcat is cleared. I clicked on the delete button to clear the Logcat, and now I will restart this activity. Now the activity has restarted. It is currently running in the foreground, which means it is active. Let's take a look at the methods that were called before the activity came to the foreground. As per the image, they should be onCreate, onStart and onResume. And in the Logcat, you can see the same order that you expect. That is, the first method to be called was onCreate, the second method was onStart, and the third method was onResume. Now let's take a look at what happens when we click on the home button. First, the onPause method is called, and then the onStop method is called. Now let's refer back to the image. In this image, it is now saying that another activity comes into the foreground, which in loose terms implies that our activity is now in the background, which is exactly what happens when we click on the home button. Our activity is no longer in the foreground as soon as we click on the home button, and therefore the onPause method is called right after that. And when the activity is no longer visible, that is, it has completely disappeared from the screen, then the onStop method is called, which is exactly what happened according to our logs. Now let's restart our application by going to our recent applications and selecting the application once again. The logs indicate that the onRestart method was called, and thereafter the onStart and onResume method were fired up. And it is once again in line with what we expect as per the image. As soon as the user navigates back to the activity, the onRestart method is called, after which the onStart and onResume methods are called, and the activity comes to the foreground and is in the running state or active state. That's exactly what is happening. Now let's try exiting our application and see what happens. Click on the exit button to exit the application. As soon as I clicked on the exit button, the onPause method was called, followed by the onStop method, and then the onDestroy method was called, which is once again in line with what we expect. The onPause method was called, thereafter the onStop, and thereafter the onDestroy method was called, at which point the activity was totally shut down. It is also worth noting that the application at no point had any control over its state. It was us as the user exiting the application, sending it to the background by clicking on the home button, or restarting it using the recent apps button. At this point, I am pretty sure that you have a firm understanding of the different lifecycle methods and the order in which they appear. With all the knowledge that we have gathered till now in this video, we are going to jump into the ClickoCounter app and find the bugs in it and fix them. So let's close this project. I will stop the project from running using the stop button. And now I will click on close project in the file menu. Now let's jump into the ClickoCounter project. Now I will type down all the code that is required for us to debug the application using the Android Activity Lifecycle methods. To do that, I will first create a log tag by typing log t and pressing tab. Now inside the onCreate, I will create a debug log by typing log d and pressing tab. Now I will overwrite all the lifecycle methods and add a debug log to each one of them. I have overridden all the lifecycle methods and added the debug log messages to each one of them. Let's start our application in a virtual device. I'll click on the green play button to start the application. The application has now started. So now, as a reminder, let's just look at the problem once again. When we click on the click new button a few times, the counts are registered as expected. But as soon as we rotate our device, the count disappears. Let's see what is happening when the device is reorienting. For that, let's open the Logcat. Now let's change the log type from verbose to debug. and search for main activity. There are a lot of logs right now, so for now, let's delete these logs. With this setup, now you will be able to see the log messages appear as soon as I change the orientation of the device. So I'll start by rotating the device. Let's see what all happened while we were rotating our device. The onPause method was called and then the onStop method was called, which implies that our activity was somehow sent to the background. Then the onDestroy method was called. We did not close our application, but somehow the application was destroyed when we were rotating our screen and then recreated. Let's try that once again. Now I will rotate the screen to the right. And once again, you see onPause, onStop, onDestroy being called one after the other, which implies that when we were rotating our screen, the application was once again destroyed. So, as of now, we know that the operating system is destroying our application when we are trying to rotate the screen. We are not destroying the application, we are not exiting the application, we did not click on the exit button even once. All we wanted to do was to rotate the screen of our mobile without losing the information that was already being displayed. So now it is amply clear that our application is being destroyed when we are trying to rotate our device. In this case, the Android operating system is destroying our application and creating it from scratch, and that is why we are losing the count. So how do we solve that? Thankfully, the solution is pretty easy. The Android developers added a couple of more methods to help in this situation. All we have to do is save the instance state and then restore the instance state. And to do that, we use two methods, namely onSaveInstanceState and onRestoreInstanceState. So let's do that. At this point, it is best that I create a count variable to store the click count, because I'll need it across the application. When the application starts, the count is set to 0. Now, let us set the count text to be equal to the count value. We will have to modify our click listener a bit here. Whenever the button is clicked, we want our count to be incremented by 1. We can also write this expression as count plus equal to 1, and that is what the Android Studio IDE is suggesting. So we will do that. Now since the count has changed, we have to show that in the UI as well. So set the text inside count text to be equal to count. At this stage, we have only refactored our code to make it look more elegant, and we have also in the process saved our count in a variable. We will use this count variable to save and restore the value of our click counts in the two functions that we have mentioned already. So let's do that. We can save the value of our count in the onSaveInstanceState by putting it in the out state. Let us see how to do that. Don't worry about what out state is and what out state isn't. Just know that out state contains a lot of information with regards to your app that is being saved by the Android operating system, so that when the app restarts, that information remains intact. Now we have to provide the key. Let's keep the key as count as well. And as the second argument, I will pass the count variable. As you can see, in the onSaveInstanceState, we are taking the out state and putting an integer into it. Integers are just numbers. We'll be covering data types in detail in the Kotlin programming tutorial. As of now, just know that it is a type of data. We are adding our data to the out state in this function by writing outstate.putInt, and we are providing the key as count and then providing the value that is stored in the variable count. By doing this, we are ensuring that when our app is destroyed, the Android operating system stores the value of the count. And to retrieve that value, we have to use the onRestoreInstanceState. Let me show you how to do that. As you can see, here I am asking the saved instance state to provide me the integer value with the key count that has been saved into it. And then I am saving that count into the count variable. This count variable is again the same variable that we defined here. Now that we have retrieved the count value, we need to set the text view to this value as well. Now let's run our application and check if everything is working. The application has started. Click on this button a couple of times. Now I will rotate the mobile. Congratulations! The app could save the count even though we rotated the device. Let's rotate it once again. As you can see, the application is now retaining the value of the count even though we are rotating the screen. I will clear the Logcat and then we will be able to see it better. Let me rotate this device once again. As you can see, when we rotated the device, the onPause, onStop and onDestroy method were called. But even though the activity was destroyed by the operating system, the value of the count was saved. Now, our application is working exactly as we expect. At this point, you must be wondering, what if we close the application and restart it? So, let's try that. I'll close the application by clicking on the back button. And when I restart the application, the count is gone. So, it is worth pointing out that this method only works when the Android operating system kills your activity and then restarts it. You will not be able to use this method if you close the activity yourself and then restart it. Now that our ClickoCounter app is working as expected, we can be rest assured that our users are going to have a good experience using it. That's all for today's video. As always, feel free to share your feedback in the comment section. If you liked the video, smash that like button. If you are new to the channel, consider subscribing. And don't forget to hit the bell icon to receive timely notifications of all future uploads. I'll see you in the next one.